Gotcha. Okay, so I'm going over and we'll look at that.
Yes,
Kind of like that.
it is.
Okay, so the instructions were to find the perimeter. And so they must have given you some numbers.
Yes, 9 yards at the top.
So this one here,
Yes,
9 yards. Okay.
on the high, 7 yards.
Oh,
Right.
did they mark it here?
Yes,
Okay, 7 yards. And they'll need one more
and the little triangle, 6 yards
right
at the
here.
bottom, on the base of the triangle.
Yeah, 6. As you can see, I'm having trouble with my computer.
Yeah, I can see that. It froze.
I'm coming out, I'm coming back in. I'm gonna see if I can. I don't know if the problem is Zoom or me. Okay, there it is. So if you want perimeter, there's all kinds of pieces. Some of these are easy to figure. So this probably not likely going to be in your homework, but not likely. If it's too complicated, it's not likely on a test. But if this is 9 and this is a rectangle, then this is 9. Everybody okay with that?
Yeah,
Okay. So this missing side, we're going to have to solve for it. And so to solve for this, and did they mark it or not?
no, didn't.
Okay. So what we're doing is putting together some of the things that we already know. And this was the Pythagorean theorem. So it was a right triangle, because see, this was a rectangle. And so a squared plus b squared is c squared, okay? And so so this is like review, in order to find the missing side, we could call this A and this B, it doesn't matter the order, is c squared. And so 6 squared is 36, and 7 squared is 49. And that equals c squared. So when you put 49 together with this looks like 5, carry 1, 85.
Yes.
These numbers right? So that this 85 is c squared.
Oh,
Then the distance here is the square root of 85. There must have been instructions about rounding.
no, just only says use pipe. That's it.
Okay, so I'm gonna do, this is not a perfect square. Square root of 85. Square root of 85, I'm going to round it to 9.2.
22.
Yeah. So this distance here is 9.2. Okay. So without seeing the problem, that's the best I can do with that. But that's how you found that missing side. Now, this is the cute one, right?
Yes.
This is circumference, but it's only half of it. So circumference equals pi times diameter. That would be a full circle. I'm going to do the full circle. So I'm going to mark it full circle.
Oh, and then you go half.
3.14, and the diameter is basically the distance all the way across. Can you tell that from the picture?
Yeah.
What is it?
7.
Correct. So 7 is the distance here. So I'm going to go, and again, I'm going to just make it simple. 3.14 times 7 21.98. Okay. Now, you think you've done all this beautiful work, but wait a minute. This is the full circle. So that would be all the way around, and we only have
Half
half. So you've got to,
divided by 2.
so this is 1, 0, 9,
4. Oh,
right?
yeah.
And so that's what we have here. 1099. I don't know if this should have been rounded one more place. It's hard to tell without looking at the problem. But now what we've done is we have 2 9s. We have a 6, we have a 9.2, and we have this. And since
Oh.
I said to use 3.14, this is accurate, although if there were rounding instructions, it might have rounded to 11, I don't know.
Rounded to at least 1 decimal place.
1 decimal place?
Yes.
Okay, now we're in business. So this was 1 decimal place. When you round this to 1 decimal place,
Uh-huh.
this
So
9,
10.
this to go to 10, which means this would round to 11.
Oh, okay.
So what you have to do now is you've done all this work,
And you side them up.
you would all add them all up.
Okay, I was trying to do the whole thing at once.
Yeah, I mean, we started with the easy thing was 9 was 9. 6 was already given. This one was the Pythagorean theorem because it was a right triangle. This was a half circle.
So
And
did you do?
I used the formula for the full circle to get a good answer.
Yeah.
Then I had to half it to get it, and then I had to round it.
I
So
see.
that was,
You do it separately, everyone.
yeah. But do you see?
Yeah.
I mean, somebody has to do this math. If they're building bridges and all this kind of stuff, somebody has to do the math and get it right.
Thank you.
I think that's a smart idea. You better get the bridges and all that stuff correct. Okay. So what I'm going to do, and if other people have questions, we can look at them. What I wanted you to realize is this week, we're going to finish chapter 11. And chapter 11 is the last week. So the final, let me see if I can look at this final. So here, this is nothing to do with us, but this is today. We have these 2 classes, and then this is where the final is. And the college actually, set final schedules. And so they actually, they set us here on the 16th from 8 to 10 a.m. For the final. And so my real question is, what do we do? We might have this be optional, the Monday for review. But this is where we stand. We have this class and this class this week to finish chapter 11. This is a potential class for review. And this was the final. You can check your calendar to confirm that, but my computer's acting up, so I didn't want to go back and forth. So chapter 11 starts with the distributive property. And I think we've kind of looked at this before. If you use the distributive property, the first thing you notice is something they would probably say simplify. Because that's the only thing you could do with this problem. And so if it was possible to add these 2, then you could, and then multiply by 3. The trouble is we have absolutely no idea what X is. It's a number and we don't know it, and we may never know it. And so the one thing we can do, if the instruction said simplify, and that's what it would say, we can distribute. And so this is something we'll demonstrate various ways. So it's the 3 times the first one plus the 3 times the second one. So this would be 3x plus 3 times 5, and I probably would have just gone straight to the answer, 3x plus 15. Is that okay with you? So we may have done that before. I wanted to show you one. This is the way the book wrote it. Okay. Now, this here, they put the minus or the negative level with this fraction line. But guess what? When my eyes are bleary and so on, I have trouble. I don't always see it very well if I'm too tired. And so I bring the negative here so that it's easier to not miss. And so there's our advantages in the next course for making this a habit. The negative on a fraction is never left in the denominator. It's either like this or like this. Leaving it in the denominator is considered poor form, and we just don't want to do that. So I think that makes it a little bit easier. Sometimes people are upset because they see fractions, but in this case, this problem, the fractions will go away. And so this is what I would do with this problem. 8x and 12 do not add. This is one term, 8x. This is another term. Here's plus. And so what I'm literally going to do is -1/4 multiplied by 8x. And then -1/4 multiplied by 12. I got kind of sloppy there. So this could be put over 1. This term, all of this together could be simplified really nicely. The 4 divides into the 8. So 4 goes into 4 once and into 8 twice. So what you have left is -1 multiplied by 2x, which is -2x. Okay. This one, -1/4 times 12, I'm going to put it over 1. I'm going to cancel or reduce the 4 and the 12. 4 goes into 4 once, into 12 3 times. So that what I have left is -1 times 3. And -1 times 3 is -3. Okay. So what turned out to be a mess simplified down to this. And so there was one more thing I wanted to talk about. And I don't know if they bring this up, but this is an algebraic expression, a term. And so if we have 3, A, B, C, D, E, F, G, it's this times this times this times this times this. This is one term. So if you keep multiplying or even dividing, you're on the same term. This will become more important as we get more letters and fewer numbers to see this. So if I have 3 A, B, C, D plus 2, this is one term, and this is the second term. So what separates terms? Either a plus sign or a minus sign. So this would be one term, this would be the other. So as long as you're multiplying or even dividing, that's all one term. And so you see it as a single group that belongs together. This, of course, would be the second term. Why did I bring this up? Well, it had to do with the previous problem. So the previous problem had negative 1/4 times 8x. Then it was plus negative 1/4 times 12. What I wanted you to see, and I kind of did it, I wanted you to see this plus sign here, which divides this into two pieces. This is the first term because notice we're multiplying and dividing. So this all goes together. This is the second term, and notice they were separated by that plus sign. So two terms. Why do I care? Because I want to smooth this out to get it just simplified, and then I'll simplify this, and adding is last. In a sense, it's order of operation, but it also is terms. And so literally, the 4 goes into 4 once, into the 8 twice. So all of this, I'm trying to put it together. And so I've got it down to negative 1 times 2x. Then the plus sign. Now I'm going to do something with this. And so this is 12 over 1. I'm going to try to make this smoothed out. Negative 1 times 3 is negative 3. So I might have written it like this. How's that? It's something that I don't always see explained explicitly, but it's critical as we go further into algebra. And I know as well as you do that if you take this course, your next course is 87. And that next course is going to do some algebra. And so we want to be ready as we can. And before I forget, do not wait 5 years to take the next course. I mean that. I want you to take it right away so you don't lose any of the skills you've been developing through this course. So plan on getting it, when you start your math, keep going until you get it all done. Okay? That's your best plan. Now you can take a poorer plan, but I don't recommend it. Okay. So let's see what else we have here. This one. So here's a problem. And so the instructions would be simplified because that's the only thing you could do with this. Notice the terms. Sometimes I write them even closer together so I can see it better. But see, that's a term, that's a term, that's a term. I have 4 terms. Okay? And so sometimes I'd write that a little bit closer. The 2/3 goes with the X, and so it's together. Now, when I look at the terms, I have an X term here and another one here. It makes sense. Remember commutative and associative where you move things around to suit yourself? This is what I'm going to do. 2/3 X, I'm going to write that first. The next one, I'm going to say plus 1/3 X. Then I'm going to write subtract 2 and then add 7. Notice these are like terms. And I think I've mentioned before that if you add, you must add like things. Well, in terms of algebra, it's like terms. So this is an X term, this is an X term, you can put them together. This is a plain number, this is a plain number, you can put them together. Don't try putting an X with a Y. Okay? Not in addition anyway. So can you see what needs to be? This is 2/3 of the X. This is 1/3 of the X. How much X is that? The instructions go like this, but the truth is, whether you have to write this step or not, I don't think so. But here it is, 2/3 plus 1/3 is 3/3. Right?
Yes.
3/3 over is 1.
Yes.
And 1x is typically written the simplest way possible. When you start with a mess in algebra or anything like that, your job is to simplify this mess into something decent. So half of this turned out to be plain old x. What did the other half turn out to be?
Plus
Negative
5.
2 plus 7 would be what?
Plus 5.
Plus 5. Notice that I had to put the plus sign to indicate I was going to a new term. I can't just say 5, because if I say 5, it looks like they're multiplied. They're not. And so here's a term, here's a term. How is that? Okay, so that's what they're trying to get us to do. And so this is simplify, combining like terms, literally would be the expression. And one of the other jobs that they teach in this first section of chapter 11 is, what if they told you what x is supposed to be? Could you get the value if x is 4? That word value, sometimes they'll say get the evaluate, but it's really value. Get the value if x is 4. Well, the minute they tell you x is 4, that means you could put 4 in for x, and you will obey the instructions of the problem. And it looks like I froze again. I don't care. You need challenges in life, right? So if they tell you, find the value of this expression, then 4 goes in here. Now, why did I use parentheses? Well, without parentheses, I think it was 54. So that's no good. So either I put a dot, but even better, I think, is parentheses, so that when you're plugging numbers in, and that's what it amounts to, you put the number inserted with parentheses around it. This is a reminder that this is multiply. And it will also help when we have harder problems or we have negative numbers or whatever. This is just a good plan. So they said put in, substitute x with 4. And so you say parentheses 4. I think it's worth the effort. Now what do you do? Well, now we can finish this. This is multiply. 5 times 4, 20, plus 2. Notice I added last. Right? Order of operation. Is that okay? Okay, here's the next one. 3x minus 9, but now x is 2/3. We're not afraid of fractions. Sometimes they work out just fine. So when I get to the x, I'm going to drop in this number. This is its replacement. So this is 3 parentheses 2/3 subtract 9. Notice the 3, I wrote it high so that I could actually, if I felt like it, call it 3/1 to keep the top and the bottom separated. This is all one term. It's multiply and divide all mixed up. This is one term that needs to be simplified before I come over here. So the 3's can cancel, and that would be great because that will clear out the fraction. So 1 times 2 is 2. 2/1 is 2. 2 subtract 9. Any answer?
-7.
Correct. You see why we did that before, where we would work with positive and negative numbers, we need it right here. Okay, here's another one. Notice they like any letter in the world. So A, X, Y, nobody cares, it's a number. So are you ready? So when you see A, we're going to go to 3. -2, parentheses, its replacement, 3 plus 7. Notice this is one term. Also, this is multiplication, which is more important than adding. And so we do it first. But in a lot of ways, what I want you to start to do is see the terms in a problem. This is a term. This is a term. They're separated by that plus sign. It could have been something else. So I want to do this first. Remember, a negative times a positive. Can you recall it? This is chapter 10, I think.
-6.
-6. So we keep bringing it down until we get it done. Plus 7. So the order doesn't matter. 7 take away 6.
1.
1. Is that okay? I want to do one more. -4y plus 9. And this time I'm inserting a -1. Do not panic. Just do the same exact thing. This is not a time for creativity. This is just methodical. So instead of y, I'll put in its number, -1 plus 9. Notice this was a term, this was a term. And so I've got to deal with this first. A negative, this is reminding you now, a negative times a negative is
Positive.
positive. And if you need to rewrite all of those rules on a single piece of paper, please do. Because that is a 4, then I still have my plus 9 to deal with, and that totals 13. How is that? Okay. They've added some strange little thing at the end of 11.1, and so I'm going to talk about it. It's talking about angles. And the first angle I want to deal with is this one. When you see that little box there, this is 90 degrees. This is called a right angle. This was what we used for the Pythagorean theorem. And so this is a right angle. So it's 90 degrees. Now they want you to be aware that you can have other kind of angles. If we went, this is the center. If we went all the way that far, this is like a clock. It's not only 90, but it's another 90. So this is 180 degrees. Is that okay? Because the 90 would be here. And then another 90. So that's 180. They call this a straight angle. You can see why. Now we have the cute ones. If it's less than 90, like that, they call it acute. Isn't that cute? Acute angle. Right? And so the main point of this, if it's past 90 and it's over here, so it's this much. So the degrees would be more than 90, maybe like a number like 120. I like funny words.
Oblique.
Obtuse. Sometimes somebody will call you obtuse. Maybe for a good reason, I don't know. But this is acute and this is obtuse, and I think they kind of make sense. Is that all right? So that's our, I don't know why they slipped this in, but what they're trying to do is the following. If you had a right angle, that much, and you knew that this was 20 degrees, could you tell me how many degrees belong to the X?
70.
It's 70. It's not a big deal. So this would have to be 70 because by calling it a right angle, it's 90 total. If we already have 20, the other one's 70. And so these are called complementary angles. If they don't ask you for that word, it's the picture will tell you what to do. This is a straight angle. The total is 180. If they told you the first one, could you figure out the second one? How much?
$100.
It would be 100. So if it, and they use that little circle like that for degrees. And so this would be 100 if this was 80. So the way I memorized it was complementary was for the 90 degrees, supplementary was for the straight angle, which is 180 degrees. So it's alphabetical. What they're trying to do is just show you these things, and maybe at a later time, they'll do something more with it, but not too much. So I think that should be okay. So the second section is going to make perfect sense. What they're going to do is start doing problems like this. Now, when you start out with numbers like this, you can guess it. And so anybody could guess the right answer, knowing that it had to total 7. But what we want, what we want will be ways to do things when the problems are not as easy to guess. And so the first job they're going to ask you to do is, if I gave you a possible answer, could you tell me if it's a good answer or not? So for instance, if I said, what about 5?
No.
Okay. So the only way to see if that's any good is do that substitution like we've been doing. Put 5 in here and 5 and 3. Does that make 7? And so you'd have to say, nope. So at first, they just want you to try a particular number and see if it's going to work. If the number that they gave me was 4, well, heck, 4 and 3. So is 4 a good answer? Yes. And so this is the ultimate test, when this side equals that side, because that's what that's saying, equals. And so when both sides are equal to 7, the same number, then obviously this was the correct answer. Okay. Now, what if they actually gave you a problem instead of telling you what the answer is? They said, find it. Okay. the whole thing, first of all, this is an equation. An equation has equal in the middle, a left side and a right side with things on both sides. This is an equation. What do you do with an equation? You solve for the missing letter. And so the whole idea is to take the steps so that X equals the correct answer. So what you're trying to do is get this side over here to say just plain X. X equals answer. What we have is X plus 4. And so the thinking is if we could just get rid of the plus 4, we'd have it. How do we do it? We do the opposite of adding. We want to get rid of plus 4. And so what we'll do is subtract 4 on the left side. And you better hurry over here and subtract 4 over here. Now, plus 4 and subtract 4 or minus 4 makes 0. Now, I could say it's 0, but obviously that's 0. What's left is X. And the answer now appears over here. What is a -2 and then another -4? How much?
-6.
-6. Okay? This idea of undoing whatever is in our way to say it like this is what we wanted. So we're going to be undoing things by doing opposites. And so let me see if I can find us a different one. Let's see. Here's one which needs a little work to begin with. Here's my equals. When you see a mess like this, your job is to clean it up. Okay? That's always step one. If you can make it better, and so what you're going to do is take each side and clean it up. And so this side, this is what we were talking about earlier. There are 3 terms, this one, and that one. 2 of them are like terms. The 3x and the subtract 2x are like, and they can be combined. So 3x minus 2x minus 2. Remember how we turn things around in commutative and associative to suit us? These two, and you don't have to write this step, but the 3x take away 2x needs to be simplified. So 3 take away 2 is
1x.
1x. And typically in algebra, we say it the simplest way possible, which would be instead of 1x, it would be x. That's assumed to be 1x. And then there's still that subtract 2 there, because that's a different term. These two are like, this was different. And so there you go. Over here, this side needs to be simplified. That's not good either. 4 take away 9. How much?
-5.
-5. So what we have is this much. So this holy mess turned out to be this. The question is, are we done yet? Answer,
9.
no. When you see the X, you find that it could be on either side, but when you see it and there's something still there, you've got to deal with it. And so this is subtract 2. So we want to do opposite of subtract 2, which is add 2. Now, some people like to put it over here. I like to put it underneath. And I would literally say +2 on both sides, so I don't lose it. So the subtract and the +2 are 0. What's left is X on this side. Over here, this is where the answer appears, -5 + 2. Negative. Remember this? if you owed $5 and you paid back $2, you would still owe 3. Okay? And so that's where our answer is. I have one more. 4, parentheses, 2a minus 3. Oh my, subtract 7a equals 2 minus 5. Maybe I got it too hard. Well, I'd call that a mess. What would you call it? So what you're going to do, you're not going to call it anything. We're going to deal with this side. And the first thing, we can't put these together because this is an A term and that's a plain number. The best we can do is distribute. So this is 4 times 2a. And I think we can do it in our heads. 4 times 2 is
8.
a.
Oh,
Now this is 4 times negative 3. So it's minus 4 times 3 is 12. Everybody good on that? 4 times 8a, 4 times 3 is 12, but it's minus. And then there was a minus 7a. 1, 2, 3 terms. The first one and the last one are like terms. If you can do it in your head, you can just say 8a take away 7a is 1a or a. If not, you rewrite it. And notice how the sign goes with each term. So 8 take away 7 is 1a. Subtract 12. And again, in algebra, we don't like to write anything extra. So 1a becomes a minus 12. These are identical. Over here, I've got this. It's very similar to the last problem. 2 subtract 5. What is our answer? We're in the negative, right? You have 2 in the positive, and then you drop down 5. You're at negative 3. I have a feeling we need to review this. Now what? Are we done yet? You see this A? It has a negative 12 on it. What do we do with negative 12?
positive 12.
Positive 12. And I'm going to say plus 12 on both sides. You don't have to throw it away like I do, but I'm doing it for emphasis. This and this drop out. I'm left with A,
9.
9. Okay. Now, I think they went with what would be the step for this one? It's only one step, fortunately. This is better. What do I need to do? You find the letter and you see if it's alone, because this is, some people are actually taught to make dotted lines so that you can see the left and the right side. I don't know if we need it, but that's the idea. This negative or subtract 8 has to go. How do we make it disappear?
Positive.
Opposite. Add 8. Add 8. So that the minus and the plus are 0. What's left is x equals, and then you put this together, 8 and negative 3, or subtract 3 is 5. And when you're done, and you know, if you put 5 in, the answer you have into the original problem, that would be 5 subtract 8 is negative 3. This is the check. So instead of the original x, I put in the 5 that I have for an answer, and I want to see if that's correct. So 5 take away 8 is negative 3. I have a good problem. So the answer is not this, That was the answer. This was to confirm it. So we never have to make a mistake because we can always check to see if it's any good. How do we like that?
Okay.
Okay. What do you think? What do you prefer I do? Should we go to the next section and get started? Or do you need a review of positive and negative numbers?
Next section.
Next section? Okay. This section is about multiply. And so if you had a little equation and it looked like that, the assumption is this is multiply,
Divide.
3x. What do?
Divide.
And so 3 divides by 3 is actually 1. And 1x is typically written x. And there's your answer 7. Now, there was sometimes you have a fraction instead of a whole number here. And so I want to look and see. This is similar, but of course it's a fraction, and we have kind of attitudes about fractions. So before we divided by 3, and so if we divide this by 1/2, we would divide this by 1/2, we would get a complex fraction, and we've actually made the problem harder than it was to begin with. Not that we couldn't survive it, but with this fraction, there is another way to clear it. And the way to clear it is to multiply by the reciprocal. So what I want to do is suggest this. Instead of 1/2, I want to multiply by 2/1. You see the advantage of that? Things are going to cancel. But the minute I multiply this side by 2/1, I have no choice but to multiply the other side by the same exact thing. So what we do to the left, we do to the right. Did this make sense? So the 2's would cancel. It's probably the best way to deal with the fractions. So all these are just 1 times x, which would be x. This is 3 times 2, which is 6. When you have that terrible feeling that maybe this isn't right, go back to the original problem and check it out. This is 1/2 multiplied by my answer, 6. Does that equal 3? Well, yes, it does. 1/2 of 6 is 3. Let me give you a different one. Instead of dividing by 1/3, I totally recommend this other approach, was to multiply by the reciprocal. Multiply by the reciprocal. How do you like it? And so the 3's would cancel. This is all 1 times a, which is a, and this is 15. I want to do this one. I up the ante right there. This can be solved by division because this is, it's not a fraction. The question is, what do I divide both sides by? This is multiply right there. Obviously, I need a 5. But if I just do positive 5, I have a negative and a positive, which is negative. What I need to divide by is not only the 5, but the negative as well. In other words, divide by the same number and the same sign. So then I come over here and I do the same exact thing. I've divided by negative 5. So negative divided by a negative is a positive 1x, which is x. Do you recall, this is division. 1 positive, 1 negative. 20 divided by 5 is 4. What's the sign? A positive.
Negative.
Can you see what you're going to have to do is you're going to have to get these rules straight. And I'm going to take a few more minutes. 2x plus 1 is 7. Oh my goodness. I upped the ante again. The left side, here's the equals. The left side has a 2 to the x and a plus 1. The order in which you do this problem makes it either easy or terribly hard. So I'm going to advise you about what to do next. The number that's added to or subtracted from that x is the number to take off first. And so the plus 1, I'm going to do first. I'm going to subtract 1 and subtract 1. Okay. So what is left? 2x. This is 0. So what's left is 2x
Equals 6.
is 6. Every time you improve this problem, it gets easier and easier. But we took the care of that. Now you would use the divide. And you would go x is 3. Any questions? 2 times 3 plus 1. Does that equal 7? It does, doesn't it?
Yeah.
I'm going to make you a list. Solving equations. And this is my own list. The book has something similar to it, but it's 4 steps. The order that you do them makes your life easy or not so easy. So the first step is to simplify each side. That could be use the distributive property, combine like terms, anything that simplifies the left side and simplifies the right side. This step here is not going to apply yet. We're going to get the letters on one side only. This will eventually come up. And so we'll save that. The next step is what I call a 2-step problem. So when you have 2x plus 1 is 11, you move the single number first. Always. Otherwise, you're going to get fractions, which you didn't have to begin with, so there's no reason to bring in fractions. So you move that single number first and then finish it. The next is 1 step. And what you do is do the opposite of whatever is there. So for instance, if it's 3x is 9, you divide. If it's x plus 3 equals 7, you subtract. In other words, you do the opposite of whatever is left. And there's just 1 step left, so you do the 1 step, and that's it. So this will eventually come in when the problems get harder. But for now, it's simplify each side. Before you work with a holy mess, clean it up. This we can skip over for now. The two-step problem, remove the single number first, the number that's either added or subtracted from the X. And finally, the last step is the obvious step. Whatever is opposite, do it. And then you've got it. So that's what I would do. And we have -3x plus 7 is -5. This is a two-step problem. First of all, this is a term and that's a term. And this is an X term, that's a plain number, they don't add. And so this is the two-step problem. So what number do we move first?
7.
7. So because it's plus, I'm going to go -7, -7. The plus and the -7 go to 0, and I'm left with this term, 3x equals -12. Okay. So now what we have is we have to get rid of the -3. And so what do? Divide by what number?
3. -3.
-3, divide by -3. What's left?
X.
X. And a negative is
Positive.
positive. Correct. There we go. Okay, so we're just about done. So any questions? Let me get out of this real fast. So that's what I want you to be working on, these two sections. Actually, it's 3, went into 3, but there's 2 sections that are due. Let me stop the recording.